Let's start with something you hear all the time. A year is 365 days long. It is a myth. Not totally wrong, not completely right either. The real story is a little more interesting. A year is actually the time it takes for our planet, Earth, to make one complete trip around the sun. We call this journey an orbit. Imagine Earth as a giant spaceship traveling on a huge invisible loop. When it gets back to its starting point, 1 year has officially passed. That journey is the basis for our entire calendar, birthdays, holidays. So, if a year is not exactly 365 days, then how long is it? Scientists have measured it very carefully. The true length of a year is about 365.242 days. That means it takes Earth about 365 days, 5 hours, 49 minutes, 12 seconds to orbit the sun. So, how do we fix this problem of a drifting calendar? The solution is something you have probably heard of, the leap year. The basic idea is simple and quite brilliant. Since Earth's orbit takes about an extra quarter of a day each year, we can let those quarters add up. After 4 years, we will have accumulated 4 quarters, which equals 1 full day. So, every 4 years, we add an extra day to the calendar to get it back in sync with Earth's orbit. This special year has 366 days instead of the usual 365, and we call it a leap year. The extra day we add is February 29th. Why February? It is mostly for historical reasons. The ancient Roman calendar, which our modern calendar is based on, went through many changes. At one point, February was the last month of the year, so it was a logical place to add or subtract days to make adjustments. So if you were born on February 29th, you have a very special birthday that only comes around once every 4 years. It is a great way to remember how our calendar works to keep time with the cosmos. Now, the leap year rule gets a little more complex. The add a day every 4 years rule is a very good approximation, but it is not perfect. Remember, the extra time in a year is 365.242 days, which is slightly less than 365.25 days. To fix this overcorrection, we have another rule, the century rule. The century rule says that a year ending in 00, like 1900 or 2000, is only a leap year if it can be divided evenly by 400. The year 2000 ends in 00, and it is divisible by 400, so it was a leap year. We had a February 29th in 2000. However, the year 1900 also ends in 00, but it is not divisible by 400. So, 1900 was not a leap year. The next century year, 2100, will also not be a leap year. It is also cool to know there is more than one way to define a year. The two main ones are the tropical year, the sidereal year. The tropical year is the one that matters for our seasons. It is the time it takes for the sun to return to the same position in our sky, and it is about 365.242 days long. The sidereal year is the time it takes for Earth to complete one full orbit around the sun relative to the distant stars, at roughly 365.256 days. Well, here is another common myth we need to bust. Many people think we have summer when Earth is closer to the sun, and winter when it is farther away. This sounds logical, but it is completely wrong. The real reason for the seasons has nothing to do with our distance from the sun. It is all about Earth's tilt. Our planet does not sit straight up and down as it orbits. Instead, it is tilted on its axis by about 23.5 degrees. This tilt is the secret ingredient that gives us spring, summer, autumn, winter. As Earth travels around the sun, its tilt means that for half of the year, the northern hemisphere is tilted toward the sun. During this time, that part of the world receives more direct sunlight. The sun's rays hit the ground at a steeper angle, concentrating their energy. Days are also longer. This combination of direct sunlight and longer days is what heats things up and gives us summer. At the same time, the southern hemisphere is tilted away from the sun, getting less direct sunlight and experiencing winter. Then, 6 months later, the situation is reversed. Earth has moved to the other side of its orbit, but its axis is still tilted in the same direction in space. Now, the northern hemisphere is tilted away from the sun. The sunlight that reaches it is less direct, spreading its energy over a larger area. The days are shorter. This is what causes winter. Meanwhile, the southern hemisphere is now tilted toward the sun, enjoying its summer. So, let us bring all these amazing ideas together. We started with the simple myth that a year is 365 days. Now we know the truth is much more fascinating. A year, the time it takes for Earth to make one trip around the sun, is actually about 365.25 days. To be even more precise, it is about 365 days, 5 hours, and 49 minutes. This small chunk of extra time is the key to understanding our calendar. It is the reason we cannot just have 365 days every single year. To handle that extra time, we invented the leap year. Most of the time, every 4 years, we add an extra day, February 29th, to let our calendar catch up. To make our calendar super accurate over centuries, we use the century rule. A year ending in 00 is only a leap year if it is divisible by 400. It is a beautiful and elegant system for keeping human time in sync with cosmic time. We also learned that the seasons are not caused by how close we are to the sun. Instead, they are a result of Earth's 23.5-degree tilt. Our calendar is a remarkable human invention designed to track that motion. It is a system built on centuries of observation and scientific understanding. The next time you see February 29th on the calendar, you will know exactly why it is there. It is not just an extra day, it is a reminder of our planet's grand journey around the sun. A year is a journey, not just a number.